free font there.
Yeah.
Download it. I'm using one that Matt put into this project here, Ghoulish. Let's bump this size up a little bit. Now I can type in a new size, or it's a little discoverability thing in Unity where any number, you can actually click on the name and it becomes a slider.
There we go. I like the Ghoulish.
We'll call this score 0. All right. Now I need some way to update this score when I do something. So let's go back to my code. And in my code here, I've got a score. Let's get a reference to that text box. And I can create it private, because I might not want it exposed to the world. And this is a text element, which by default is actually not there. You have to bring in. By default, it's not going to be found. So if I right-click on it, I can just resolve the reference. It exists in this namespace, unityengine.ui.
It's one nice things about using Visual Studio.
Oh, I love it. So we have this element right here. Now, this is just a private variable. How do we set it? Well, we can search for it when this game object starts up. But I'm going to use one of my favorite features of Unity, and I'm going to display this field in the editor. If I make it public, it will automatically show up in the editor. But then it's public that other classes can read that value. I don't want that. I want this still private, but I want to expose it in the editor. So I'm going to add the serialized field attribute to it. And simply by doing that, if I go back to Unity, and I look at my cube with controller, what we'll find here, notice.
Oh, there it is.
I've got that text box there. It's not assigned, so I will just drag this on over. Voila. It's assigned. And now in my code, after I do my collision and destroy, I can say, hey, I want to update my text. It's a text box with a text property to. Now you could use string.format here, which I would typically do, but just to save a second or two here, I'm just going to say underscore score dot toString. Alrighty, let's see what happens, shall we?
I'm excited. I'm hoping we get 3 points.
All right, now let's try moving this over. Oh, you know what I forgot to do?
What's that?
Increment my score. Score plus plus.
You even had your comment in there for it, too.
Increment score. That meant the overall process, which the UI is so essential, but so is the others, right?
Yeah, you can't forget to increment the score, yeah.
All right, so let's move this guy over here. 1, 2, 3. Easy enough. These exact same concepts we just did right here, where we read input, move an object. Typically, you'll actually see this done in fixed update.
Why are we doing it in fixed update?
So, update calls per frame. If your game is running 40 frames a second, that's running 40. This code is getting called 40 times a second. With fixed update, the physics engine in Unity works at a fixed time step, which you can define in Unity. I think it's 0.02 of a second, so 50 times a second it runs. And because physics, they need a consistent value to do it in. So this method gets called basically 50 times a second. It's a fixed time, and that's good for physics. There's rules sometimes we can use one or the other. I cover that a little bit more in the MSDN magazine article because sometimes you want linear motion, sometimes you want scaling motion, so one's good for one, one's good for the other. But typically, anytime you move a rigid body, I should say often, you'll see in fixed update.
Makes a lot more sense now.
So now, these same concepts here, colliding with an object and moving an object and updating the UI, they are essential concepts, which will bring us to, when we create our game, piecing all the elements together. But first, people are going to notice when I run this game, they're going to say, all right, this is a 2.5D game. We're talking about 3D here. How do I run around in a 3D world? And I just want to show this real fast because it's so essential to understand the options that are out there. So that's going to bring me to something called character controllers. And if I go to my Unity project, the same one I was just using, I'm going to disable that camera. And I have brought in Unity's sample assets, it's called. Right here. In the asset store, you can download sample assets. And there's an AI character, AI car. They've got this little first-person and third-person controller. So I just imported that into my project. Once I did that, I can come over here under standard assets. I'm sorry, under sample assets, characters. Now I could do a first-person controller, and I could just simply, let me find one of my cubes so I can place this right near my cube. I can drag and drop this guy right here. Run my game.
Oh, we have a game.
And I have footsteps. I don't know if you can hear those or not. I can jump. So I can do that with a first-person controller. I can delete my first-person controller. I could come in here with a third-person controller. And I could run around with that third-person controller as well.
And these assets are really great just to bring in and take a look at to see how they're actually building these assets.
Now you'll notice the funny thing is I'm reading input on the cube, and my characters are reading all of my full input. That's why you see both of them running around. And look at that guy runs into the cube, knocks him around. So really, really cool things you can do easily. Since you want to get up and running in a game fast, I highly recommend downloading those asset packs and checking it out. For what we did in this next game, Zombie Pumpkin Slayers, we kind of wrote our own code on there using the exact same principles that I just showed in that demo scene there. Exact same principles. So first, let's cover what we did on the title screen here. So our title screen that we did, let's run the game here so you can see it. You guys are going to see the game now. At least we'll see the title screen first. We'll slowly unveil it.
It's always the best way. You can't give away everything right away.
Give away everything. You got it.
It's kind of my favorite music track too.
I love the feel of this music for this game. It's just
Zombie
right.
Surfer dude.
Zombie Pumpkin Slayer. We've got this animation going on here. Got some UI elements here. And when I click on this button, my scene will load. So before we do that though, let's just kind of do a walkthrough here. This is nothing more than some UI elements placed out here. Let's go like this to unveil what this really is. Remember, on that last level, when I added a text box, it added a canvas element for me. That's what this new UI system does. Any UI elements add this canvas here. So what's a UI element? If you take an image and drag it on your screen for what Carl was doing, for example, that's a sprite running around on the screen. That's not a UI element, typically, although it can be. When I think of a UI element, think of a heads-up display in a game. You know, you've got a score in the upper left-hand corner, and it shows you your power-ups in the lower right-hand corner. That's, to me, that's a UI, a GUI system. They're fixed on the screen, although they don't have to be. With the new UI system in Unity, they can follow characters around. You can actually have any UI object anywhere in your scene. But for the sake of this, for what I'm doing here on the title screen and for the score and whatnot in the game, I'm using the UI system. And anytime you add any UI component, it creates a canvas for you. Oops, and this event system, which is how it detects what you're clicking on. So under the UI menu, you've got a couple basic things. You have a panel, which is nothing more than an image. You have a button, which is nothing more than an image with text and a script on it. You have text, you have another image. So a lot of these are based off of images. And literally everything I have here, except for nothing, actually, except for this button here. So I've got these images right here. Let's see each one. So I've got my background. Let's zoom in on this guy a little. You can see that bluish image in the background I disable. That's nothing more than an image right here. And early on I talked about a game object being this name and tag and a transform. With the new UI system, you have a rect transform, which is a different object. Similar to the regular transform, but this is fixed more for 2D. You have a whole anchoring system on here that you can anchor things in the corners so they will stretch with the screen. Very similar to what you'll find in Visual Studio for when the new .NET stuff came out and the new Windows Forms and XAML, how you can take elements and dock them in there. Very, very similar to that.
So I can dock elements inside of other elements as well then?
Dock other elements inside of elements, inside of other elements, inside of other elements, make them all scale out in front of each other, do some really cool things there. So these are nothing more than images with a script on here, which basically just says, hey, what source image is this? And it's just a sprite in our scene. When Carl was doing the character animations, they were just sprites. These are just sprites assigned to this script. Same thing all down the line here. We've got Pumpkin Row, right there, those pumpkins. We've got the Blue Glow, just nothing more than a glow. Blue Glow. Pumpkin Row.
That sounds like a band.
I know, I was thinking
Pumpkin Row.
Now you've got Skid Row stuck in my head. Thanks. We got the logo, Zombie Pumpkin Slayer. Notice here, we can set, if we want to stretch, see how it's stretching with it and is growing?
Oh, that's beautiful,
because
too.
I've set that in the horizontal direction. I want to expand. I can expand in horizontally and vertically if I want as well. So and down here is a button, which is nothing more than an image and a script on there. With these scripts, it can detect a click and call new a method. There's a couple different ways of doing this in the UI system. And also, you can have different transitions. So when you mouse over your button, you can play different animation. These are just 2D animations, just like Carl showed in the 2D session. And they will create these for you. When you basically create a new button, let's just create a new one to see this here. UI button. If I go to animation,
look at that.
Auto-generate animations. If I click on that, it says, hey, what animation names do you want this? And it'll create them all for you. So it's real easy to do. And the button, again, is nothing more than an image with a button script and a text component underneath. So real basic components that make up this UI system to do some powerful stuff on there. Now, when you click on the button, again, there's a couple different ways to do this. In my button script, I'm saying, this game object, I want you to send a message to it. Send a message. And again, there's several ways to do this. I can think of actually 3 off the top of my head. A direct reference. You can hook into this event in code. Actually 4. You can use your event system, or you can specify a method here. So this send message function says, give me the text of a function name on this component. So it exists in code somewhere on here. Let's open the code. This function is what I'm going to call when you click on the button. So let's go back to that. This here is going to call the play click button. The play clicked method, I should say. And in order to load a new level, in other words, load a new scene, they should probably call this load scene. It would make more sense to somebody first learning this. You give the name of your scene. Now that scene has to exist in your build. File, build settings.
With a check mark next to it.
Yes, file, build settings. This is where all the goodness happens. This is where you can select all your platforms. It's also Control-Shift-B if you like hotkeys. It's the same hotkeys Visual Studio. And in here, you can say, I want this platform, set that as my default. These are all the scenes here. You don't have to have them all in here.
Ooh.
You can kind of keep them all pretty simple if you want. Let's do this here. Remove a bunch of these. And actually, just to show you this is how the empty dialog box is right here to start. I can add on the current scene. We've got that one, okay. Now I've got the title scene in my build. Any other scenes I want, I can just take those scenes, maybe drag them into here. And that's
Pretty
it. So
cool little shortcut there.
These are the names of the scenes that must exist in order to call that code. So I need a title or arena, Atom main. Now let's run this guy. So we have our title screen. When the game runs, we'll click on that. It calls application load level. Now we get to unveil. What do we get to unveil?
The actual game itself. You guys ready for
Zombie
Pumpkin
Slayers. All right, let's look at this. Now, let's kind of dissect all this out here. Before I do that, let's make sure we get the right slide here talking about this, because this is of epic proportions. We don't want to miss this. Demo, creating zombie pumpkin slayers. This is going to be the gameplay aspect of it. This is going to model all of the basic components that we just looked at with those cubes. It might look complex-ish. Let's run this and see what happens. Actually, let's make this bigger when we run this. You can click maximize on play. Let's run that. So we created this over actually the last few days. We had a bunch of different ideas. So these guys come up to the tombstone here, and they try to attack it. There's some particle coming out of that tombstone. There's randomly spawning pumpkins here. They're playing different animations. And your job is just to keep smacking the heck out of these pumpkins that are here. Let me eliminate these real quick.
What an awesome set of graphics on there as well. Talk about the power. Cool lighting effects.
So the Matt is the, I did all the code integration behind this. Matt is the mastermind behind, of course, all these graphics on here. So let's pick this apart here. Let's see what we've got in this scene. We've got more guys coming here. This is what I was talking about way earlier, though, so I can just show you while I'm here. We can do per frame advancing here. You can see my little guys running, each little frame there. So if you need to do fine-grained debugging, you can use that a lot. Okay, so let's pick this scene apart. We have a world that's a 3D model. Let's go in the wireframe here. You can see it's kind of these little, it's a little bit dark in there, so we can see in the background here, if I go like that, actually, let's do textured wire. So we've got a level. You can buy these off the asset store. You can make them yourselves. We're going to talk about this a little bit in the optimization session tomorrow. We've got more 3D models that are just kind of plunked in here. If we look at this guy here, just a mesh render.
Pretty simple,
that shows us. Very, very simple. Our pumpkins are just also meshes. And they have a little controller script. They have a rigid body on them, so they're on the ground, moving across the ground. They have a pumpkin controller. It's got a speed. And I simply have a variable defined here for hit colors. If you notice when I was hitting it with a hammer, it would flash a color. And when the pumpkin gets smashed, we play a particle system. Remember I showed earlier, real quick, I did a particle system.
Look.
So this particular particle system I used on here was part of the Tune FX pack, which is a really cool particle system on there. You can find some free ones and pay ones on Unity Asset Store, some really neat ones. And I basically say, hey, I need a reference to a particle system I want to play here. When this pumpkin starts up here, we find a couple components. So this pumpkin has animations. We need a reference to our animator component. That's going to control what we're going to animate, what we're going to do. I need a reference to my renderer element. Well, what do we do with our renderer element? We're doing nothing more than flashing a red color. That's why we need this component. Now movement, I'm just a little caching a reference here. Sometimes we'll cover this in optimization section. It's best to cache certain things, saves on what's called garbage collection and allocating memory later on, sometimes if you do things up front. We'll talk about that again more in optimization section. I have a game controller object in my scene. Game controller is just essentially a near empty game object. It has no visual properties. And a game controller you find in a lot of games. It's a script, an object in your scene that has some code methods responsible for doing something. It's kind of like the coordinator in your game. In this game, this one is responsible for updating the UI for a score, exactly like we saw on the Cube demo. And we have some random stuff, some random spawning.
It's kind of like the orchestrator.
The orchestrator, yes,
There we
exactly. Go. Now our pumpkins, let's click on this pumpkin here. Matt designed this pumpkin, and with them we have in our enemies folder a bunch of pumpkin enemies. So we have a model for this pumpkin. Let's find, here we go. This is the model that Matt created for the pumpkin. And then separately are all these FBX files, all the animation data contained within them. Actually, in these cases, these are .ma. These are dropped in right from Maya, but they can also be FBX files. And in here, if I expand it, I can see I've got some sort of data in here, a bounce animation. It's going to be pretty tiny here. But you can tell something's bouncing up and down there. So the animation data is simply combined in these separate files here. So what we're doing with that animation data at runtime is we have an animator component. Let me shift spacebar here to make this bigger. And what the animator component does here is this simply will take a animation state. And let me get out of this again to show you what an animation state is. These are simply, these little cubes here, these rectangles, do nothing more, absolutely nothing more than point to an animation file. These are the files that your animator creates, or you get from the Unity Asset Store. You can get literally tens of thousands. I think Mixamo in their catalog has over 10,000 animations available.
Wow.
So these point simply to an animation file. If we click on one, we can see what it points to here. Bounce 1, bounce 2.
What's this system called, by the way?
This is Mechanim.
Mechanim, okay.
In Unity, you had several different animation systems. You had the legacy animation system and Mechanim, which introduced these ways of blending animations together and these state machines. Gives you a nice visual way to kind of see everything that's going on. So, for example, let's take our zombie kid.
Ooh.
So our zombie kid here, let's run this. And let me actually make this not maximize. And we've heard the soundtrack many, many times. So let's mute that.
Oh,
Sorry.
there goes our...
I know, it's cool. So Zombie Kid here, we get this auto live link. We can see what's playing right now. Idle's playing. And in code, I can control it. I can say, as soon as I read input, transition to run. Well, how do I do that? I can set up little variables here. I can create a new variable, a Boolean variable called whatever I want. And I can control these in code through that animator component. So I could say, I want you to transition to get hit when I set hit equals to true. How do I know when hit equals true to transition over? I click on the arrow. And I'm saying right now the default is play animation, go right to this one. I don't want that. That's saying play the animation idle, and when you're done playing it, go to get hit. I want to actually trigger this only when hit is equal to true or false or whatever. as soon as that value becomes true, it switches. And you set those values in code. So if I go over to my project here, let's go back to our pumpkin controller. Right here. So let's say, for example, this was the get hit. If I wanted to call that animation right here, that was the hit variable I added, the hit Boolean value. If I wanted to trigger that animation, all I would say is animator dot set bool and give it the name of it, hit, comma true. And that would actually transition that animation state. And you can mix them a bunch together. You can do some really, really cool things. As I mentioned early on, I think in the first session, that Mechanim allows you to have a character potentially shooting from the upper body and running with the lower body. And you can actually take multiple animation files and mix them all together. The sample assets have a great example of that. They use a whole bunch of different animations for running and turning to blend between all those
where you kind
states.
of tilt over to the side a little bit while
right.
making a right turn.
So we've got simply some code that's controlling the pumpkin state. And that code here, let's go back to this. Fixed update, the movement of the pumpkins, all we are doing. The pumpkin's entire existence says as soon as we come to existence, whenever this fixed update, remember that runs with the physics step, that happens 50 times a second. Whenever we call fixed update, we're setting the velocity of our pumpkin in some vector. The forward vector, and since we're using this transform direction, is the forward vector for our pumpkin, meaning wherever our pumpkin is rotated, we're moving them that way. So how does that come into play in this scene? I have two spawn points. They're just random. A spawn point is nothing more than an empty game object. That's all. It's an empty game object. There's no properties to it whatsoever. And I can simply, when I spawn something, just create it at that location. So I've got two spawn points here.
Spawn left and spawn right, I guess?
See them right across opposite sides of the tombstone there. Spawn right, spawn left. So all they do is an object gets created right here and just starts moving in its forward direction. I create an object here and I rotate it towards the cross and it just starts moving in the direction. All that is accomplished simply by one line of code. Set its velocity to move forward. That's it. Now, the main character, so that's the pumpkin. They're pretty dumb. I hate to even call it AI because it's really, 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 really basic. The main character, Zombie Kid here. Notice when I highlight Zombie Kid, what do we see? On his little hammer there, I've got this big green box around it. That big green box just so happens to be...
It's a collider, isn't it? Ooh, he's far down that chain, too.
Yeah, and you'll see this a lot. When somebody gives you a 3D model, there are actually many levels nested deep of various bones, so to say, various aspects of this character. So if we look at Zombie Kid, we've got body, root, lower back, chest. You can work your way down. So right clavicle, right shoulder, right elbow, wrist. It comes like that. And typically when you get models and somebody gives it to you, they're already auto-generated like that outside of like Maya or whatever the tool is. You can control that in that particular tool, but you'll see this quite often. And so what I did was I just found the club in here, and all I did was I added a box collider to it right here.
So I could do the same thing and put one around his head for headshots.
You could put one around his head. Now the reason I added the box collider here is because I want to know when this hammer hits a pumpkin. So I added a box collider here, and my pumpkins, on the other hand, they have a sphere collider.
Ah.
So when this hits that, it triggers an event. Remember we saw the events before?
Well, it's kind of hard to read, too.
Code here's...
Can we get it a little bigger?
Crank this code up a bit.
There we go. Now
Remember, anytime that we call collision events here, on collision enter. Now there's actually, what I did in this case was very slightly different. And you might notice here that this checkbox is checked off on our collider. So a collider can serve two purposes. A collider can be for physical interactions. We saw when we took our cubes and ran them into each other that they literally pushed one out of the way. It had a velocity, hit the other one, and moved it. That's a collider. And a rigid body, because we have mass. You can also have a collider as what's called a trigger. And what you are telling Unity is do not do any physical interaction but notify me. In other words, when one object comes within range of another's collider, Don't push it out of the way. Let it go through. But you notify me in code that something has happened.
You can start whole event sequences using this.
Exactly.
Conversations or...
Exactly. So in this case here, I don't want this pumpkin to get pushed out of the way. I want this really animation to go right through it, but I want to be notified that that trigger happened, and then I can decrement count and just destroy my pumpkin. To your point, what you said, you can spawn off conversations, right? If I have, let's say you could converse with a zombie sitting here. I could just take this guy and add on let's just do a sphere collider, just as an example here. Scale this out a ton and set it equal to a trigger. Unity will now notify my code event. I have to have, I'll show you this here.
One important thing to talk about is it's notifying the code event for that particular object.
For that particular object. And when you have a trigger, it's no longer on collision enter, it's on trigger enter. Very similar purpose. It's just one notifies you and there's a physical effect. One notifies you with no physical effect. So all I'm saying here, let's say your character comes in within this region. Bam, your zombie comes to life. Or you start conversing with it. That's how regions are detected inside of Unity and many other systems as well.
Now we can have him stop talking to me if I walk outside of that too.
Yeah, so there's 3 with a trigger. You have 3 events typically used in that case. You have what we're doing here, on trigger enter. You have on trigger stay, which fires near every frame that you're within here. So this on trigger enter gets fired once when you move into this range. As long as you're in that range, on trigger stay keeps getting, and then you'll get on trigger exit when you get on out of there. So 3 events that you can use for that to detect exactly what the state of that character is in there. We added score, so let's do this. This is on our player. This is on our zombie kid. As soon as that hammer hits something called a pumpkin, we're checking to see if we are currently using our smash animations. Why would we do that? I'll tell you why. If we're standing there not doing anything, and a pumpkin runs right into our hammer, do we want it to apply damage?
Yeah.
Kill all the pumpkins. We could do it that way. I wanted somebody to run around this game and always have to hit them as opposed to stand there and let pumpkins run into them and die. So I wanted to make sure I was playing a smash animation before I would dole out any damage. That's all this code does right here. If I happen to be playing a smash animation, then I would give me a reference to that pumpkin's controller, and I call a method on there called apply damage, which does nothing more than we basically had on our...
So you could take these same concepts and apply them to other types of fighting games, per se.
Absolutely. This is exactly how it's done. You call apply damage, it reduces the amount of your health. If your health gets less than or equal to 0, because maybe multiple things are hitting you at once, you always want to check if it's less than or equal to, then you start a coroutine. And this is kind of a weird-looking thing.
Die.
But so not only die is a weird-looking thing, but start coroutine. A lot of folks, if you're joining us today, happen to be a .NET developer or C or C++, whatever, and you're used to spawning off threads on a system, the question comes into play, how can I do threading inside of Unity? You don't spawn off threads in Unity. You start off coroutines. Unity works off a coroutine-based system. You can read about it on the net. It manages all that for optimization's sake on the back end. So you basically tell Unity, I have the intent to start a routine. You give it the data, and it will schedule it in its preemptive system on the back end. And so that's start coroutine. So I'm essentially saying, do the equivalent of starting off some other processing thread here, but in Unity use coroutines, and I just call my die method. And die does
exactly like it sounds.
Exactly like it sounds here. I have some comments because we're going to build upon this more tomorrow. Die instantiates my particle system, and in this case it actually deactivates the pumpkin, and we'll talk more on that tomorrow, why we would want to do that when we do our optimizations. And then we simply game controller increase score. And that's where we get our pumpkin count increasing on there. All the same concepts. So what we're doing here is we're using a rigid body to move our pumpkins. We are using a rigid body to move our player and our... I should have just overall bumped up the font size. Right here, we are doing the exact same thing on our player. We're reading the input from your keys and mapping that over to its vector. Same thing that we do with the cubes. And we have some other code in here. This guy right here,
This looks a lot like 2D just with an extra Z, doesn't it?